Welcome to Study Loop.
We'll be using the concept of the particle in the box to find the energy of the photon that is released in a transition between two energy levels that are given here. So the energy level of a cubical box, which has x, y, and z components, is given as follows. Nx, the energy level in the x, squared plus ny, energy level in the y plus nz, energy level in the z, all squared values, multiplied by Planck's constant divided by 8 times the mass of the particle times the length of the box L squared. So we are told that this is going from the 2-2-1 state to the 1-1-1 state for as far as Nx, Ny, and Nz are concerned. So we also know that the change in energy levels gives the energy of the photon delta E, which is equal to Planck's constant times the speed of light divided by the wavelength. So if we find delta E, we can find the wavelength. So delta here is going to be equal to the energy level in the 2-2-1 state. So we can E 2-2-1 minus the energy level in 1-1-1 state. So we simply plug in 2-1 for X, Ny, and Nz accordingly, and then 1-1-1 for Nx, Ny, and Nz accordingly, and carry out the operation. So it gives you 2 squared plus 2 squared plus 1 squared, which is 9. This is 9 minus 1 squared plus 1 squared plus 1 squared, which is 3. This is minus 3, and both values are multiplied by Planck's constant divided by 8mL. So that's why I pulled that out. So this is divided by 8mL. Okay. So for M, we're using 9.11 times 10 to the minus 31 kilograms. H, of course, again, is Planck's constant. So this is 6.63 times 10 to the minus 34 joule seconds. L, the length of the box, we're told is 8 times 10 to the minus 11 meters. So now we have an expression for delta E. So we can solve for lambda by plugging this expression in for delta E. So is hc over delta E. From the above equation, we can delta E is equal to 6h. Since 9 minus 6 divided by 8L squared. Which of course is equal to, you can change this. You can change 6/8. You can simplify this down to 3/4. So plug it in for delta E. We obtain a new expression, which is 4mL squared times the speed of light divided by 3 times Planck's constant. Since we had one Planck's constant on top, and then delta E has a Planck's constant squared, the squared value cancels, and you're left with one Planck's constant on the bottom. So plugging these values in, we find that lambda is equal to 351 times 10 to the minus 9 meters, or 3.51 nanometers. You can write it minus 9 meters, or you can write it as nanometers.